Hello, welcome PlayBASIC Coders. I'll make this very short. We're on the Athlon system here. I'm capturing this on a phone. So, last conversation I was looking at some of the overhead in some of the internally bound command sets, which is things like the array command sets, and noticed the comparisons were still treated much the same way as what those functions were. They didn't need to be, they shouldn't be really. I'm actually sitting at you might have seen this before, which I bought a few years ago. I've got the Athlon system at the bottom there, set this up again today. So I made a set of these instructions, the same level of operations as things like addition, subtractions. So we run the comparison test. Alright, so we get about 5 seconds to run through, and each test is doing about, I think it's 10,000 times 5, so about 50,000 comparisons. And this is build 6 of this C3. These last couple of builds of 165 are really just addressing little bugs that have shown up or things that are missing. So that's pretty good. Alright, let's try the test in beta 5. Don't think this one was uploaded actually. I'll put them both up anyway. Just about 8 seconds to run that. Let's try 164p4. So the timings for each one are about 2.5 times slower compared to a 165, so about 14 seconds there, about doubling each time. One more test. Alright, let's try the learning edition, just to check it out. Some of those are almost 5-6 times slower in this than the retail. The P is about double this performance, and 165 is double again. 28 seconds. So that's all I wanted to say. And so I've got this little system here set up with its own little spot. I can do things on it. At some point I'll have to move the contents of this Athlon system onto a newer system. I do have one, it's actually around the corner that I use for video production. But this has everything on it. You know, it's been sitting here for such a long time. This test, by the way, was made 2004. So most of these old comparisons, I actually have a whole folder of these old, just very focused, very simple comparisons. You know, just because this test here shows that 165 is faster, it doesn't necessarily mean that in the real world, in a real world program, you get, you know, double the performance. Because often, you know, in here we're doing nothing but comparisons inside a loop, for example. That bit of code there. We're doing 5 comparisons inside the loop, storing it in a temp. Now, in the real world, you're generally just doing a comparison and then a branch. So they're not. There's no linear correlation between the two. But it's always good to have things performing better than this, of course. There was one demo on here. I'm actually running the old version. This is 164L, it's a learning edition. See if it even runs actually. Not sure if it will. No, it won't. Alright, just update now to today's build. It's a texture mapping demo. It's doing intersections on the Zs. It's not prospectively correct, but it's sort of somewhere in the middle. It's like a rough approximation. It gives a reasonable look. At certain orientations, you can see the texture wobble all over the place though. It works okay for crowd chatting. This is what I used actually in Visible Worlds back in the day. This code base is a chunked together version of that. A quick look through it, I guess. It's pretty much all done in arrays and this parallel array stuff. 2002, this was originally written. Scary, isn't it? 17 was the PB version of it. Scary. It used to be almost all integer, but the floating point stuff in here is actually for the Z buffering. This is from a library I wrote years ago for Dark Basic of all things to do. Classic DB didn't have types, so you end up using parallel arrays. Same sort of structure of arrays with just different data types in them and Emacs buffers. And I think it's simulating screens in one-dimensional integer arrays. So I've updated it somewhat. I've got types and things like that in here for doing the pixel stuff. Creating a surface, which is just making the image, which is in the array system. So these arrays here. PBSync, which is just doing copying the buffer to the screen. CLS is just a clear array command. I think fill memory would be better than those actually. So here's a triangle drawer. We're trying to get triangle color with Z. So we've got color triangle with Z, I should say. Coordinates, a Z coordinate. The color, and we should just be interpolating across the surface. These are clipping for scan lines or for the polygon sections. That's our fill loop. That's the interpolation down the edges, the triangle edges, and then these are the actual scan line loops. Rounding our coordinates to, we're stepping on pixel centers, so the left-hand coordinate will be rounded to the left and the right hand is rounded to the right. So if they ever share a space, you have two triangles beside each other, the pixels that run down the shared edge shouldn't overlap. So if you want to have transparency, you'll see there'll be a seam down between them. The clipping stuff there, they're pretty heavy really for just a PB frame to do that stuff. Just in a loop, just computing the Z, checking the current screen depth against the current depth, and if we're closer, we draw it in, set the Z, and keep going. There's some ugliness in here. My little comment there, make less cheesy. So we shouldn't do that up front, because if we need to swap these around, we're doing a bunch of swaps on having variables that don't need to be there, etc. We swap the RGBs and then split them apart. It's probably a better way to go. Just to sort the triangle from top to bottom so you can render it from top downwards. Z's int, Z's floating point. Our screen space stuff is actually integer. Yeah. Anyway, I don't know if this is put on the forum or not. I have no idea now. This was a much bigger library. It had, you could create cubes and just polygon shapes in general, spheres, etc. Anything that DB could do, this library, because it had to mimic what DB could do for the Visible Worlds. So I sat down and wrote this. We didn't just do it in a day. It took a while to build it, and then stuck it all together. And the goal was to make it so that the render would mimic DB at the time, and so if you work out the visibility of objects we're seeing, and you can actually then have a reference render on screen that would give you a good indication of what it would look like loaded into PlayBASIC. This is not for that. This is actually just the rendering code for doing the visualizations. But the good thing about this is that I've actually got this little thing set up separately now, so I don't have to kind of swap around where this system was and the laptop is currently sitting now, which I kind of carry between inside the house and outside the house. The other system was sort of sitting over in the corner, which wasn't much fun. But we should be some way to being more productive. Can't guarantee it, but we'll try and get some more done. It looks better on camera than it does on the screen. It runs alright. This is running on the Athlon system, not on the laptop, of course. The system is single core. It's I think 2007, somewhere in there, 2006. Not too bad. Anyway, I'll leave you to it. Have fun. I'll see you next time. Bye.